last video, I explained deviation produced by a prism. So in this video, let us see angle of minimum deviation and how to find the refractive index of the material of the prism. So this is the expression for deviation produced by a prism. D is equal to I1 plus I2 minus A, where I1 and I2 are the angle of incidence and angle of emergence. Here I1, here I2. And A is the angle of the prism. If you go on changing the angle of incidence, angle of deviation will be going on decreasing, and after reaching a minimum value, then deviation will increase. So this is the graph between angle of incidence at the first phase I1 and the angle of deviation is marked along the y-axis. Angle of incidence in the first phase is marked along the x-axis. You can see as the angle of incidence in the first phase increases, angle of deviation is going on decreasing and it reaches a minimum value. That is the angle of minimum deviation. At the angle of minimum deviation, I1 is equal to I2. Angle of incidence here and the angle of refraction, or that means angle of emergence here, I2. They are equal. I1 is equal to I2, and so we can write it as I. Similarly, R1, R2 will become equal. So you can write R1 is equal to R2 is equal to R. At the angle of minimum deviation, you can see the light ray inside the prism is parallel to the base of the prism. Now, using this, we can get the refractive index. So in this expression, deviation we can put capital D, that is angle of minimum deviation. At that time, I1 is equal to I2, so we can write I plus I. So this is 2I minus A. So minimum deviation is equal to 2I minus A. After rearranging, you can get I is equal to A plus capital D by 2. Take this minus A to the side, so A plus D. Then 2I is A plus D, so I is equal to A plus D by 2. Then at the angle of minimum deviation, R1 is equal to R2, that is equal to R. Then the last derivation we saw, R1 plus R2 is equal to A. So at the minimum deviation, R1 and R2 are equal, so you can write R plus R. So 2R is equal to A. From this we can get R is equal to A by 2. Then as per Snell's law, refractive index is equal to sin I by sin R. Mu is equal to sin I by sin R. So we can substitute for I, A plus D by 2, and for R we can substitute A by 2. So using this expression, we can find the refractive index of the material of the prism. Here A is the angle of the prism and capital D is the angle of minimum deviation. Angle of the prism and angle of minimum deviations can be determined using spectrometer. Now let us see an example. Angle of the prism is given to be 60 degree. Angle of minimum deviation is 37 degree. Refractive index is given by this relation. Mu is equal to sin A plus D by 2 divided by sin A by 2. We can substitute for angle of the prism 60 degree and for the angle of minimum deviation 37 degree. 60 plus 37 divided by 2, 48.5 degree. 60 divided by 2, 30 degree. Then sin 48.5 degree is 0.75. Sin 30 degree is 0.5. So when you divide, you will get the answer 1 point. Refractive index of the material of the prism is 1.5.